Alright, so back a while ago, you'll remember this. I told you to memorize this nice chart that we had. Oh, I know. It's exciting. I've memorized it already, so there's really nothing new here. Alright, so we fill this in. Sine of 0 is? It's not 0? It is 0? Sine of 0 is 0? Alright, 0. Sine of pi over 6? 1/2. Sine of pi over 4? Sine of pi over 3? Sine of pi over 2? 1. And then how do I do the cosine row? Just do the exact same numbers in the opposite order. So cosine starts at 1, and then it goes square root of 3 over 2, square root of 2 over 2, 1/2, and 0. And once I know sine and cosine, how do I get tangent? Sine over cosine. 0 divided by 1. 0. This one's the hard one. 1/2 divided by square root of 3 over 2 turns out to be 1 over the square root of 3, or if you rationalize it, square root of 3 over 3. Either of those answers is good by me. What's square root of 2 over 2 divided by square root of 2 over 2? 1. When you divide something by itself, you get 1. This one, square root of 3 over 2 over 1/2. You flip the 1/2 and multiply. That one turns out to be square root of 3. And 1 over 0. Undefined. All right, today we're going to make a new chart. How is the new chart different from the old chart? No, I want to know what's the sine of 0 degrees. 0. What's the sine of 30 degrees? A half. What's the sine of 45 degrees? Square root of 2. Square root of 3 over 2. How is this chart any different from the other chart? It's not. It's just in degrees. So not only should you have this chart memorized in radians, you should also have this chart memorized in degrees. And they're exactly the same. You just got to remember which is which. So I'll fill the rest of it in. Alright, so we're going to know this chart, and we're going to know it cold. Anytime the teacher stands at the door and asks me a question, like what's the sine of 60 degrees, you're going to tell me? Square root of 3 over 2. And if you ask me the tangent of 30 degrees, you'll tell me? That's a 30 degrees. I started to say 90. I started to say 90 and then I changed my mind. So you're both right. Wasn't a fair question. All right, so what if I ask you, why is the sine of 45 degrees square root of 2 over 2? All right, so if you were to convert, if I were to start with pi over 4 radians, and I asked you to convert that to degrees, how do you convert pi over 4 to degrees?
180 degrees over pi.
Is it 180 over pi or pi over 180? Yes, it's one of those two. Why 180 over pi? Well, more importantly is this is 180 degrees over pi radians. More importantly, I need the radians to cancel with that one as radians. And it turns out that you do get exactly 45 degrees. The other thing you could do is you could draw yourself a nice triangle. Here's a nice triangle. It's a right triangle. It's got a 90-degree angle right there. and it's got a 45-degree angle right there. If this angle is 45 degrees, how much is the other angle? It has to be 45 also. How come?
It's an isosceles triangle.
Right, you add up all the angles, subtract from 180, it has to be 45. And it makes it an isosceles triangle. That's a fancy big word. What does isosceles triangle mean? It means two out of the three sides are the same. If this angle is 45 degrees and that angle is 45 degrees, when the angles are equal, the sides have to be equal. So how long is this side? Give me a number that you like.
4.
1, that's right. That one is length 1. You guys got to make it easy on me. 4, 21, picking crazy numbers like that. If this one is side 1, how long is this side over here? 1, because it's an isosceles triangle. And then how long is the hypotenuse? Now, it can't be 1 because it's not an equilateral triangle. It's not 2. Square root of 2, because we would have c squared equals 1 squared plus 1 squared. So c would be the square root of 2. So if I asked you to do the sine of 45 degrees, what sign again? Opposite over hypotenuse. Opposite would be 1. Hypotenuse would be square root of 2. Is it the same as square root of 2 over 2? Yeah, because you rationalize, you multiply top and bottom by square root of 2. You get square root of 2 over 2. So the sine of 45 degrees really is exactly the same as pi over 4. They both happen to be square root of 2 over 2. Would it have made a difference if I'd have gone with one of your crazy numbers and put a 4 here? Would I have gotten a different answer?
No.
No, why not? Because this would be 4, which means that one would also be 4. So if this were 4 and this were 4, this would be how much? Square root of 32, because it would be 4 squared plus 4 squared. So this would be square root of 32. So sine of 45 degrees in this triangle would be 4 over the square root of 32. Is that the same as square root of 2 over 2? No? Yes? I hope it's the same. This is 4 divided by, what can you do with square root of 32? I could multiply top and bottom by square root of 32. I was thinking I could make it smaller. Both ways would work. I was thinking I could write square root of 32 as square root of 16 times 2. And then the square root of 16 is 4, so that 4 on bottom cancels with that 4 on top. And I do get the same answer. So it doesn't matter how big we call these sides originally, but we make it small to make our... I would rationalize just like I did here. I'd multiply top and bottom by square root of 2. All right, how about a 30, 60, 90 triangle? So this is a right triangle. This one's 30 degrees. This one's 60 degrees. All right. Typically the way we do this is we decide that this side is going to be length 1. And the hypotenuse is going to be length 2. If this side has length 1 and that side has length 2, how long is the other side? Square root of 3, because we would have, this would be a squared plus 1 squared would be 2 squared. So a squared would be 4 minus 1, which is 3. So a would have to be the square root of 3. And so you can see that we get all the things on the chart that I promised you we get. Sine of 30 degrees is A half. Opposite over hypotenuse, 1/2. And cosine of 30 degrees is adjacent over hypotenuse, square root of 3 over 2. And then from the same triangle, I could do sine of 60 degrees and cosine of 60 degrees. The only thing that changes is I'm now dealing with this angle, 60 degrees here. If this is 60 degrees, how long is its opposite? It's that one down there, it's A. So cosine of 60 degrees really is square root of, or sine of 60 degrees really is square root of 3 over 2. And cosine of 60 degrees really is 1/2. Alright, so like I said, this chart, you should know it absolutely in radians, you should know it absolutely in degrees also. I should be able to ask you either of those systems and you should be able to give me the right answer. Questions about that? I don't memorize the triangles. Personally, I memorize this chart. But if some people prefer to draw the triangles,
That's what I was
and use it, and that's fine. If I ask you what's the sine of 60 degrees, you need to be able to give me that answer. And how you get it, I don't really care. Personally, I like the chart. That's my choice. But I've seen a lot of students who prefer the triangles. And either way is good by me. You can also memorize the whole unit circle if you want to, yeah. That's a good way to go. And that way you know a lot more information even, because you know all the things in quadrant 2 and 3 and 4.
Yeah.
Speaking of quadrants 2 and quadrant 3 and quadrant 4, what if I asked you to find the sine of 120 degrees? Why is it the same as sine of 60 but in a different quadrant? I heard the right word. Reference angle, yeah. Where's 120 degrees? It's in quadrant number 2. So here's 120 degrees. This angle right here is called the reference angle, and that angle happens to be 60 degrees. How do you know that one's 60 degrees? Because 180 minus 120 would have to be the 60 that's left over. So yes, sine of 120 degrees is exactly the same as sine of 60 degrees. How come it's exactly the same? How come I don't have to put a minus sign in front of it? Because we're in quadrant 2 and sine is positive in quadrant 2. And the sine of 60 degrees is? Square root of 3 over 2? Sine of 60 degrees. Square root of 3 over 2 it says in my chart. Yeah, it's a fun game. It's one of my favorite games to talk people out of the right answer. I know. Math teachers typically tend to be mean like that. No, just me? Oh no, I know math teachers who are much meaner than me. I live with one of them. All right, cosine.
That's on recording too.
I would say it if she was here. She would say it if I were there. Yeah, but no. Cosine of 225 degrees.
45?
And how do you know that one's 45? I mean, you're doing that so fast right in your head.
And 225, you can't get that.
Okay, you certainly can't get a 225 from a 30 or a 60 because it's got a 5 in it. All right, so where is 225 degrees? It's in quadrant 3, so it's right here. So the reference angle is this little angle right there, and that one happens to be 45 degrees. And how did you get 45 degrees? That's right.
Yeah, minus 3. I'm thinking.
No, you're right. You're thinking correctly. It's
225 minus 180. Okay.
all right. So when we were in quadrant number 2, we went 180 minus the angle we were given. And that gave us 60 degrees. When you're in quadrant 3, you start with your angle 225, and you subtract 180. And that does give you 45 degrees. So this is cosine of 45 degrees, except this time I need a little minus sign. Why do I need a little minus sign? Cosine is negative in quadrant number 3. So this is negative square root of 2 over 2. Questions on that? This is a lot of it, yeah. Find the reference angle and then evaluate the functions.
My problem when it comes to 214.
All right, so that's an excellent question. Jada, did you have a question also?
I was just going to ask if, like, in this part we were going to do, like, cotangent and stuff like that.
Oh, yeah. So let's combine our two tricks here. Cotangent of 214 degrees. All right, so my first question would be, what's the reference angle?
34.
Well, how would you find it? Where's 214 degrees? Which quadrant? It's in quadrant number 3. So I would take 214 minus 180, and you get 34. So this is the same as cotangent of 34. Do I need a little minus sign?
Yeah.
No.
I hear yes, and I see no's.
Tangent's positive in the third quadrant.
I'm in quadrant number 3, correct?
It's positive.
Who's positive in quadrant 3?
Tangent.
Tangent and
Cotangent.
cotangent. So do I need a little minus sign?
No.
No.
Can we kill again?
Now, do I know cotangent of 34 degrees? Is that one of the ones on my chart? No. So what do I do? I don't cry.
Is it sine plus cosine?
No, it's easier than that.
You just plug in your calculator.
If it's not one of these numbers on our chart, our only option really is to plug it into our calculator. So we're going to plug it into our calculator. Now, of course, when we use a calculator, the first thing we're going to do is we're going to hit the mode button and we're going to make sure we're in degrees because this problem is in degrees. And that's one of the most common mistakes people make is they forget to switch the calculator back and forth. All right, so my calculator doesn't have a cotangent button.
1 over 10.
It's 1 over tangent. So when I type this into my calculator, I have to type it in as 1 divided by tangent 34 degrees. My calculator does not have a cotangent button. So I go 1 divided by cotangent, what divided by tangent I mean, 34. And we would write the answer is about 1.48. We'll round to 2 decimal places, I guess. Questions on that one?
Can you do like cotangent or something like that with a regular?
Cotangent or something with a regular number?
Yeah.
All right. How about since we did cosecant, take cotangent, how about we do a cosecant? And by a regular number, I assume you mean one that shows up on the chart. Oh, we already did 120, so let's pick a new one. We already did 225. Let's do 300.
Good.
Cosecant of 300 degrees. Where is 300 degrees? Quadrant 1, 2, 3, or 4?
4.
Quadrant 4. So we have 300 degrees is over here somewhere. So I heard two choices. I heard, would the reference number be 30 or would the reference number be 60? And the correct answer is yes, it's one of those two. 60, because when we find the reference, we always measure to the x-axis, never to the y-axis. If I measure from here to the y-axis, I would get 30 degrees. But you never do that for the reference. For the reference, you always go back to the x-axis. So, in quadrant 4, To find the reference angle, you take 360 degrees minus your original angle, which turns out to be 60 degrees. So this is cosecant 60 degrees. Positive or negative? Again, I hear disconsent.
It's negative.
It would be.
Because it's
In quadrant 4, who's positive? Cosine, and what goes with cosine? Secant. So in quadrant 4, cosine and secant are positive, which means cosecant must be negative. All right, so now cosecant of 60 degrees. I look on my chart, I find sine of 60 degrees. It's square root of 3 over 2. So cosecant is going to be, well, we got to flip it, 2 over root 3, because we're doing cosecant, we got to flip it.
And you can leave it like that.
As far as I'm concerned, I'm perfectly happy if you leave your answer just like that. If you don't like that and you want to rationalize, you could. It's minus 2 square root of 3 over 3.
Yeah.
Webassine cares?
I don't think Webassine cares. If you put your answer in like that, I do believe Webassine will take it. I'm pretty sure it does. So, and I don't care if you rationalize or not. That's a wonderful answer as far as I'm concerned. Tangent. Seven pi over 6.
You want it in degrees.
Oh, I don't want it in degrees because it's in radians. I'm perfectly happy with both systems. Equally happy with both systems, in fact. Root 3 over 3? How'd you get root 3 over 3? How do you know the reference angle is pi over 6? Well, that's not true, but pi over 6 is still the right answer. 7 pi over 6 plus pi over 6 is 8 pi over 6, which is not 360 degrees. What quadrant is it in?
3.
Quadrant 3. Back in quadrant 3, when we were working in degrees, for quadrant 3, we took our original angle and we subtracted 180. If we're dealing with radians, we're going to take our original angle and subtract pi, because pi and 180 degrees are the same angle. So that's 7 pi over 6 minus 6 pi over 6, which is pi over 6. Pi over 6 is the reference. Tangent pi over 6. Do I need a little negative sign?
No.
No, because
Tangent positive in quadrant.
I'm in quadrant 3 and tangent is positive in quadrant 3. Tangent of pi over 6?
Square root of 3 over 3.
Square root of 3 over 3. How about, well, haven't we done yet? We haven't done any secants yet. Secant of, oh, go ahead.
Is it okay if you change the
It's okay, but I would like to see you actually get out of that habit. Since we're in pre-calculus, I'm assuming that a lot of you plan on taking calculus. And when you take calculus, you never use degrees. You only ever use radians. And the reason is, when we do calculus, we do something called derivatives. And when you deal with derivatives and you have trig functions, derivatives only work in radians. They do not work in degrees. And derivatives, you'll spend like half of Calc 1 studying derivatives. So when you study derivatives, everything has to be in radians. There's not a choice. So, you could do it in calculus. You could take the derivative, you could convert to degrees, get your answer, and then convert back. It just takes too long after a while. You really need to get used to working in radians. All right, so how about secant of, I don't know, I need a good angle here. How about pi over 4? No, that one's too easy. How about 7 pi over 3. What can you tell me about 7 pi over 3? It's more than 360 degrees. And even better would be to say it's more than 2 pi radians. Why is it more than 2 pi radians? Because 7 over 3 is bigger than 2, isn't it? So what do you do if it's more than 360 degrees or more than 2 pi radians? Subtract. No, we don't try. We subtract 2 pi from it. We make it to be angle less than 2 pi radians. So what you should do if you have an angle, and it doesn't matter if it's in degrees or in radians, if it's bigger than 2 pi, if it's bigger than 360 degrees, subtract to make it smaller than 360 degrees or smaller than 2 pi. So this is 7 pi over 3 minus 6 pi over 3, which is pi over 3. And that turns out to be nice because pi over 3 is where? It's in quadrant 1. I don't have to worry about reference angles if I'm in quadrant 1. And I know the answer is going to be positive. What's the secant of pi over 3? Let's see, pi over 3, that's up here. If I'm dealing with secant, I'm looking at the cosine row. The answer would be 2 over 1, which is 2. Nice clean answer. Yeah, we don't get too many of those. Nice clean answer. I'll give you another one with a nice clean answer. How about that? I want the, which function are we going to use? Tangent or cotangent? All right, we'll go with tangent, I guess. I heard that one first. And my angle is going to be, I got to figure it out plus first. 1,170 degrees. What would you do? Crying's not an option. Panic. Okay, panic's acceptable.
Yes.
It's bigger than 360, so you're going to subtract 360, aren't you? All right, so if I subtract 360, I get tangent of 810.
Keep doing it.
Do it again.
Again.
Tangent of 450.
What was that?
One more time.
Yeah, tangent of that.
Tangent of 90. And tangent of 90 is undefined. All right, so that happens sometimes.
All that for just that.
All that for undefined, yeah. Annoying, isn't it? Yeah. But that happens sometimes. Sometimes your angles are really big, so sometimes you have to subtract 180 or 360 more than once. And the same thing could happen with a really big negative angle. I might give you cotangent of oh my god, better this time. How about negative 690 degrees? What would you do if you have a really big negative angle like that? Add 360. Oops. If I add 360, I get negative 330. What would you do with that? Add 360 again. I would keep adding 360s until I get it to be a positive angle. If I add 360 again, I'll get cotangent of 30 degrees. And cotangent of 30 degrees? Three over square root of 3. Or if you remember that tangent of 30 is also 1 over the square root of 3. So when I flip it, I just get square root of 3. So you could write your answer a couple ways. Square root of 3 would be a nice answer. 3 over square root of 3 would also be acceptable. All right, last question for the day. How do you find area of a triangle? 1/2 base height. And that's really easy to do if your triangle's a right triangle. Ooh, that's not very straight, but you get the idea. Let's say I told you, I don't know, how long is our base?
21.
12. And how tall is our triangle? 8. So what would the area of this triangle be? Well, it would be 1/2 times 12 times 8, which is 6 times 8, which is 48. So finding the area of a triangle is really, really easy if it's a right triangle. What if it's not a right triangle?
Look at that cross on this triangle.
All right, so this angle right here, I don't know how much is that angle. How many? 20 degrees, okay. 130? What's 130? This top angle is 130 degrees, okay. Which means this one is 30 degrees, okay. How long is this side down here? 21. Somebody's been wanting to use 21. I've heard 21 a bunch of times. This side over here, I guess this one can be 23. All right, so for the area, we would have 1/2 times base times height. That would be 1/2. How long is the base? 21. But here's the problem. What's the height? We don't know. The height, by definition, is that distance right there where that's a right angle. So this is our height. So how tall is that?
We can figure it out.
And how can we figure it out?
Pythagorean theorem.
I can't use the Pythagorean theorem. To use the Pythagorean theorem, I would need to know just this distance. And then I could use that, and I could use the Pythagorean theorem. I don't know how long that is either. Sine of 20 degrees equals h over 23. Where'd that come from? This is a right triangle now, isn't it? So sine of 20 would be opposite, which is the height, over the adjacent, which would be 23. So h is 23 sine 20 degrees. 23 sine 20 degrees. And then I could grab my calculator and I could figure that out.
7.8.
7.8. 7.7?
7.8.
7.87. All right, so in general, if you have a triangle, any old triangle, and you know two of the sides, we'll call these two sides A and B, and you know this angle theta, you can find the area. Area is 1/2 times base times height, and I write the word base out because base in this case is going to be which letter? A. Base turns out to be A. So that's 1/2 A. And then what's the height? Well, to find the height, you do the same trick. There's H. So how tall is that triangle? Well, sine of angle theta would be what? Opposite over hypotenuse, H over B. So H is B sine theta. So if you know the length of two sides, and you know the angle in between them, area is 1/2 times the length of the first side times the length of the second side times the sine of that angle. All right, so if we just drew a triangle here, and I told you this angle is 15 degrees, and this side has length 36, and this one has length 40. What's the area of that triangle? It's 1/2 times 36 times sine 15 degrees times one more thing. It's 40. Because it turned out to be 1/2, multiply the first side, multiply the second side, multiply sine of the angle. So it's just 1/2 times 36 times 40 times sine 15. I grab my calculator. Calculator says that's about 186.35 square units, whatever units I'm dealing with in that problem. Questions?